Okay. Okay, cool. So let's start tonight with study unit 7. So we will focus on looking at sampling distribution of the mean and proportions, and again with study unit 7, a lot of the things that we have done in study unit 6 we will nearly carry over to this unit. Um, so we will again need to know how to calculate a z, when you have a z value, how to use the z tables. So again, we will work around those things. So what I've again just included is some of the some notes for you that you can look at, and um, I will share it again later tonight. Um, I just didn't get to it earlier today to share it, but so first we will look at sampling distributions. Then specifically when we look at sampling with the mean. Um, so you will see when we get to some of the questions, sometimes they talk about population, they give you information about the population. Sometimes they talk about sample, give you information about the sample. So depending on those two things, we will, in certain instances, do different things or use different tables to get to it. But don't worry about it now. We will, when we get to those examples, we will work through it as well. Okay, so then what we will find is, and I'm gonna skip through these things as I will share it. You can look at it. Um, I rather want to get for us to two things that is important, and I just want to see if there is. Okay, so I will just write on here as well that we have it. Um, so please, this is one of the things that is very important. Um, Sampling error. So I've seen in all the last few assignments, in all of the exams, this is something that they like to ask. So when you go through the study unit, you will see that the formula for the Z has now changed a bit. So in study unit 6, we assumed that everything was working with a population. So we had, this was your standard formula to work out the Z. Study unit 7, because we bring in the sample component, a sample always has a sample size. Okay, so the formula changes slightly. We'll still use this formula then to calculate the Z, but where I want to bring in the sampling error is as this part here at the bottom is called the sampling error. Okay, so just when we get to questions, sometimes they give you all the information to work out the Z, but they're actually asking you only to work out the sampling error. So your sampling error is basically your standard deviation divided by the square root of your sample. So this is important because you are very likely to get a question around that in both assignments and and in your exam later in the year. What we will then also look at is you will look at the sample error. There will be one for the sample mean, there's one for the sample deviation, and in the last part of study unit 7, we also look at sample proportions. So there will be one for that as well. The sample proportion one will look a bit different. The formula will look a bit different, but we will get to that later in the study unit as well. Okay, so I'm again gonna have those things that you guys can work through it. I want to see where I have the formula so that we can just, sorry, I should have hidden a lot of these because it's not needed. Okay. So here is just, sorry about this. My slides are now a bit macabre from last time I created it. There's been a few extra things that came in. Okay. So let me rather get you to okay, so in this, so here, what has happened here? Okay, I must just check what happened with these slides. Okay, let me just give me a minute just to see if I have actually the right slide. So let me just, sorry for this. I think something went a bit haywire in my slide pack. So let me just quickly see where the right slide pack is that I need to work with. It seems like something went wrong with my, can't find the other slide pack, so I'm just quickly updating 1 or 2 on this pack, and then we can just continue again. Okay, so let me get you back to important, and then we can continue. Sorry about that. Okay, so what I think is important for you is, and again, this is very small, but it is in your study guide, is that that is basically how we're going to work out the Z. So it is, like I showed in the previous slide, that component stays exactly the same, but we are introducing then the sample size that they would talk about. Okay, so when we work it out for the mean, we will get the Z. As we did last time with the Z, we will go to the Z table, and then depending on what they ask us, we will need to look what is important. So this is for the sample mean, but then there is also one for the sample proportion. And let me just make this view also a bit bigger. Okay, perfect. Okay, so with a sample proportion, the words that they will also talk about and how they will use it is different. So in the questions they will talk about 10 out of 40, or so you will already see that you're working nearly with things that are in a proportion. So they will not talk about the mean or anything like that. Then the other thing that is important is when they talk about, and we see it in the mean as well, where the standard deviation is known or unknown. So with your proportions, there's two different formulas that we will use if it is known or unknown. And then the other thing that is important is when we calculate the z, it does look a bit different than the formulas that we are used to. So it will bring in the proportion that they will normally talk about. So that will be the proportion that they would talk about, like in a mean. That will be the one that we normally refer to the x in the mean calculation. I will tell you that number. And then this formula here at the bottom, that will be again your standard error. So like the standard error with your mean, this pi 1 minus pi divided by n will be your standard error when we work with proportions. Okay, so, but as we get more into some of the problems, we will definitely look at all these different options. Okay, so basically we're moving on from chapter 6 into chapter 7 with those kind of problems that we will look at. Okay, so I know this is very small, but every time I'll bring up the tables that are in your study guide as well, just so that you can see how to use that. Okay, so in study unit 7, it's very, and let's be be honest, it's very unlikely that they will just tell you the z is equal to something. So in study unit 6, you had it where they might have given you information you needed to, and you calculated the z. Some questions they gave you what the z is, and you only needed to work out the probability. The chances that in study unit 7 and the questions around study unit 7 that they actually just give you the z number is very slim. So with that in mind, the formula is, as always, going to be now this formula, the x minus mean divided by the standard deviation divided by the square root of n. Okay, so let's see what they tell us. They give us the n. So we know that the n is 16, so we have that sorted. They tell us that we're working with a normal distribution, that the mean is 1,000. So we know at least that top one, we've got the mean standard deviation of 200. So they tell us the standard deviation is 200. So you can see the only thing that they still need to give us is X. They tell us use the standard normal Z table to calculate the probability that Z will be bigger than 1050. Okay, so we can basically do that and say, okay, they tell us Z bigger than 1050. So I nearly already do that. 1050. We know that the mean is 100. That will already give us, or if we go to the next level, 50 over something. That's just the easier one for me to calculate. Then we need to divide by standard deviation, which is 200 divided by the square root of n. N is 16, also we can actually say that is divided by 4. So 200 divided by 4 is 50. So in the end, we would need to say, calculate that Z is actually bigger than 1. Okay, so then for Z bigger than 1, what I normally first do is, let's get the graph, sort it out. That is normally the 0. So if Z is, say, there equal to 1, we know that, and we're looking for that area. Remember, Z bigger than 1. So we're looking for that area. We know already that this portion is 0,5. So whatever that small portion is, it is going to be smaller than 0.5. So out of these, I could have already eliminated 1, 2, 3 options. Okay. So let's look at the Z table. Just want to bring the one out of the study guide into play. The Z table now, unfortunately, again, it is part of chapter 6. So when you look for the Z table, it will be part of chapter 6 again. So remember, we're looking for that small area. So if we look at Z equal to 1, we got the 0,8413. So we know that this area is 0,8413. That's not what we're looking for, but look at what was the first option. So if you just looked at that table and you forgot that we're actually looking for that smallest piece, you could have had option 1 as the correct one, but it's not. Okay, so we're looking for that smaller piece. So 1 minus 0,8413 will give us the yellow portion, and that is then 0,1587. What we could have done, and that would have been option 2, what we could have done as well is gone to the negative table, because we know that we work with symmetry. So if that was 1, That side is -1, so it should give you the same. If we go to -1, we get 0.1587, which is exactly the same. So we could have used the negative table because we're only looking for that small area. So that small area would have been replicated on this side, and it would have been exactly the same size. So again, depending on what is easiest for you to work with, you can use both. The one that you will say, I need to subtract the big part to get that, or I use the negative table because of the symmetry of normal distributions. The -1 and the 1, those two areas are exactly the same size. So again, please, there's not a right or wrong in the two methods. It's both you can use. Um, so just the one that is the easiest for you to use. Okay, how does it make sense? What's your reaction to a question like this?
Sorry, Jean.
Yes.
Let's just say we didn't go further to minus from 1, and we got that answer 0.8413. Would we get it totally wrong, or would there be a mark or two allocated?
See, and that is what I think you would have now seen in your last assignment. You got like weird marks, like a half mark and a mark, and so you will get a mark. In the exam, they are not as lenient. So in the exam, it is probably going to be wrong, but I will find out for you how if they're gonna use that same method in the exam as well. But you will definitely, in your assignments, you would have gotten probably, if it was a 4-point mark, you would probably have gotten 2 or something like that. If it was a 2-point mark, you probably would have gotten a half or 1. So definitely in the assignments, you will get a mark or 2 for that answer. And I think you would have seen now with the last assignment, there was like weird points that you guys were getting. So like a half mark or 1.5 or 4 points. So there will be some points that you will definitely get.
If you got this question right, how many marks would you get for this question in the exam?
This is probably a 4-point question. It's probably a 4-point question. If I only give you a Z, or if I said Z was 1, or you needed to work out Z bigger than 1, then it's a 2-point question. But because you needed to do all of this calculation, it will be a 4-point question. So yeah. And especially with study unit 7 that we're looking at the sample, so where you have the mean that we're looking at, we've got the proportion that we're looking at. So definitely in the exam, this will be definitely a few marks, like 4 points. Okay, let's go to the next one, which again, it's not happened in this question, but please just always be on the lookout for the things that they are in the same format. So if we're talking time, that it is all in seconds or minutes or hours. If we talking weight, that it is all, if I give you kilograms, make sure everything is in kilograms. Because I have seen that now suddenly they throw in 500 grams or something like that, and you use the 500 instead of putting it into kilograms. So just please, when you look at, I think here they just gave us numbers, but when they put a weight or a time or kilometers or anything like that with the question, please just make sure that the units are exactly the same. So here they ask us, so they tell us the distribution of weights of a last group of high school students is normally distributed with a mean standard deviation. What is the probability of a large group of high school students will be more than 63 kilograms? Okay, so again, we can look at the Z. They tell us the students will be more than, so more than is greater. So we've got the 63. We've got the 55. Check if I need to change screens or something that this doesn't appear again. Interesting, in here, they don't tell us how big or how many students. Okay, so in this instance, they don't tell us N, so we then just work with, like in study unit 6. So again, be on the lookout, especially between study unit 6, 7, and 8, where they can nearly throw this into the set that you might have option 6 that says you don't have, or sorry, not option 6, option 5 that says you don't have enough information because you're nearly looking for that N. But if I don't give it to you, we assume that it is not needed. So let's just see 63 minus 55. What is that? 8. 8 divided by 5 is, so we're looking at something that is bigger than, Z bigger than 1.6. Okay, so again, we could have gone, and again, let me first, I would draw it. Okay, so there's 1.6. So we're looking for that area. That is 0. So that small area again is going to be smaller than 0.5. So again, we could have eliminated that, eliminated that. One of those two are probably the answer, but let's see. So firstly, if we go to the positive table, we go to 1.6. So we get the 0.9452, which was that option, but we need to say 1 minus it. That is wrong. I must now do my calculation right. So 1 minus that is 0.0548, which is option 4. Okay, so we could have now just checked if we look at negative 1.6, and there we have it 0.0548. 0.0548. So again, very similar to the previous one, we're looking for that smaller area, we can get it by 1 minus this big area. It will give us that, but we can also then look at the negative table because we know that it is on the left and the right, it's exactly the same because it's symmetrical. So there could have also been from a negative table, we could have gotten the answer. Okay, so very similar to the previous one, but there are some others that we will also look at. Okay, so then the next one. So they tell you a normal distributed population has a mean of that, standard deviation, the standard error of a sample mean if a sample size is equal to 100. Okay, so we have a formula to calculate the Z. But just remember, we are calculating the standard error. Okay, so standard error is only that portion there. The standard error is only this. This is... Okay, so the standard error is only when you say standard deviation divided by the square root in n. Standard deviation is 12. Your n is square root of 100. So it is 12 divided by 10, which will give you 1.2. And that is option 3. So in this one, you needed to work out standard error. They did not give you enough information to work out the Z because they never told you what the X is. Just be aware in the exam, they are more likely to give you the X value as well. Because sometimes when a lot of the students would continue and assume you need to work out the Z. So just be careful in the exam and even in your assignments that they might give you the Z or sorry, the X value as well. But actually just wanted the standard error. Standard error is the standard deviation divided by n or the square root of n, and that will give you the answer. Okay, so standard error, also something that you might just, again, when we went back nearly to what was it, study unit 3. So just be, sometimes they can give you the variance. And remember, we don't like to work with a variance, so we always want to nearly take the square root of the variance to get you the standard deviation. So just make sure that sometimes they do use variance, and that you just need to square root the variance to get the standard deviation. Okay, so we basically now did a standard where we used the Z to get to the probability, one where there was a sample size, one where there wasn't a sample size. So basically one that looked exactly like a study unit 6 example. Then there was questions around the standard error. And now nearly they giving you a lot of information that can be used in a definition question. So if you look at this, you will even see that there's maybe in option 3 that you need to calculate something. Which one is incorrect? So again, giving you a few things on theory that you need to understand. That is why also again, if you can, there's these slides that might help you, if it is possible to print it or have it at hand when you're writing exams. It does help. Again, you guys are writing open book, so you are allowed to have all this notes and things with you. There's no problem with that. The only thing is that it should be you writing it and nobody else. But you are allowed to have all these notes and things to assist you. So please, if you are able to have it or on a different screen or print it or some way, you can use it to help you in the exam. Okay, so let's go through the definitions and the things that they talk about. So the first one, they tell us the sampling distribution of the mean will have a mean as the original population from which the samples were drawn. That is correct. So if you go back to nearly the beginning of your study, Unit 7, in that explanation part, that is where they talk about this. So the sampling distribution of the mean will have a mean as the original population from which the population or the sample were drawn. So that is correct. The sample deviation of a sampling distribution of a mean is also called the standard error. We've just done it. So when there is sampling involved, it is the standard error. When the population mean is that, population standard deviation n, the standard error. So interesting in this one, now they ask you to work out the standard error. Normally in a definition question they don't. So this again is an interesting one. So 25 divided by the square root of 64, so 25 divided by 8. That will give you the 3,125. Okay, so that is also correct. Now what is interesting is confidence intervals we haven't done yet. So this is probably a question that you will only get in study unit 8. So if your assignment, and I don't know if I already said which study units, but it will probably 7 and 8. This then might be a very good question that they can ask because we still need to get the confidence interval. A confidence interval is an estimate for which there is a specified degree of certainty that the population parameter will be in the interval. Okay, lots of words. It is true. So what, and let me quickly, so when we look, if we when we look at this diagram that I nearly draw each time, so if that is your mean of 0, remember that is a parameter. If we go back to study unit 1, it feels ages ago when we looked at population parameters. What was it? Sample goes with, what goes sample with? If somebody can quickly, it's always parameters and population. Sample go with statistics. Okay, so we basically now talking about population parameters. So if when we worked out for 1.6 on this side, and I said, okay, that there's a negative 1.6 on this side, and we have the probability between this. This is actually a confidence interval around the 0. So it might seem that confidence interval is going to be something new, but you actually have been working with the idea of confidence intervals already. We just have not looked at the formulas around it and those kind of things. But this would have been a confidence interval around 0.0. So we will later in study unit 8 talk about a 90% confidence or 95% confidence or 99% confidence. All that it then means is that this probability that we're working out every time, that is or a 90 or a 95 or 99 percent probability. So in a sense, we have been working with confidence intervals, but not directly with the formulas around it. So the one that is incorrect is option 5, but let's look at, so we use the t-distribution for statistical inference of a population mean when the population standard deviation is known. So that is the one that is wrong. We only use it when it is unknown. Okay, so when it is unknown, we use the t-distribution. Okay, so that is why number 5 is incorrect. Okay, so let's go to the next question. I just quickly want to give me a minute or two. I just want to put on the inverter. The power just went off. So at least my laptop is fine. I just want to put on lights and things like that. Just give me a minute, please. Okay, cool. Let's continue. Let me just let me know if you can see the slideshow again. Somebody just give me a thumbs up or something that you can just see it again. Cool. Okay. Awesome. Okay, let's continue. So the next one another question around this. So again, they tell us it's normally distributed. They give us a population mean, population standard deviation. So we know from a previous one, if we're only looking at the t distribution really in the next study unit, but to identify t distribution with standard deviation should be unknown, or the population standard deviation should be unknown. We know the population standard deviation, so that's fine. The probability of a random sample of 25 items, so we know that we're looking at n. We have the n value, but this is an interesting one. They want us to what will have a mean that is between 79 and 85. So they're actually asking us, and we will work out with two z's, but they're actually asking us to work out the probability that it is between 79 and 85. Okay, so this one is probably, and Peter, I think you ask for around marks. So something like this will be probably the most marks that they will allocate to a question. So this is probably a 4-point, if you want to go to the extreme of the marks, because in this one you would need to calculate two z values. You will need to again decide if you want to use the positive table, the negative table, and then most likely need to subtract two probabilities from one another. Okay, so let's do this one. So we're going to work between 85 and 87. So we know the 1x is 85. They told us the mean is 80. So while that one is on the one side, we know the smaller one is, as we do the one, we just do the other one, but we nearly do the same. We're going to divide both by standard deviation divided by the square root of the sample, standard deviation divided by the square root of the sample. Okay, so at the top of this one, 85 minus 80 is 5. 10 divided, that will become 5. So 10 divided by 5 is 2. So that will be 2.5. On this side, we set with minus 1. Okay, so that's going to be an interesting one. Minus 1, we set that is, again, the same, 10 divided by 5, which is 2. So on this side, we're sitting with minus 0.5. Okay, so we will need to look at the graph. So that one is in the middle, is 0. Somewhere here is 2.5. Somewhere here is minus 0.5. Okay, so there's no ways that I would by now can say eliminate anything. I will probably only say eliminate the first one. That looks very big, but that would just be a guess. Now it's very difficult to say, okay, it's going to be bigger than 0.5. It's not going to be bigger. So nothing nearly that one can now quickly eliminate. And we need to work out this area in yellow. So again, if we look at our two tables, well, one, there's nothing that we can see. There's something in the middle. So we need to do something with a negative, and we can do something with a positive. Okay, so how I look at this is to say, and let's take that yellow component out. So we know that when we use the positive table, I will actually can calculate, get that whole purple area. Okay, then if I use the negative table, I can get that red area. So if I then say the purple area minus the red area, that will give us the yellow that we had originally. Okay, so this is how I would do it nearly, is to say, okay, let's get that whole area. That whole area that is less than 2.5, we can get that from the positive table. That smaller area, the red area, we can get from a negative table. If I subtract those two, I'm left with a yellow that I'm looking for. So let's see if that will work. So let's go to the positive table, 2.5. So if we look at 2.5, 0.9938. And nearly to just let me know it's correct is by giving you that as one of the options. So again, in the exam, Peter, if you said 0.9938, which I said was probably way too big, that might actually give you half point or point, because it was one of the things that you needed to calculate in any case. Okay, let's go to the negative table. The minus 0.5 minus 0.5, 0.3085, 3085. So again, 3085. There was an option. So if somebody chose that option, again, probably you would get 1 out of 4 in the assignment. But we need to subtract those two from one another. So let me just get my calculator. So 0.9938 minus 0.3085. So that answer is 0.6853. 6853, which is option 3. Look at, again, sneaky. I don't like this at all, that they do something like that, because again, that's just very easy to make the mistake when you read it out to swap the two around. Yeah, so that is the way that I would have done it. There's a few other ways that you can do it as well. So another way of could have been that. So let me see, where can I want to nearly include a new slide. So remember, we'll need to find out what makes this computer do this. So remember, this was 2.5. That was 0.5. So you could have gotten that one. So we used the negative. So that was 0.3085. Remember, when we look at Z distribution, symmetry, so I could get this small area with 2.5, I could get that same value at the minus 2.5. So 0,0062, 0,0062. So this area now is what I'm looking for. So in this instance, I would have said 1 minus that, the 0,3085, minus the 0,0062. So let's see if that would have worked as well. I should have tested it before I've done this now, but let's quickly check. So if I said 1 minus 0.3085, that gives me 0,6915 minus 0.0062. So then I also get 0,6853. 6853. So exactly the same I got if I did it this way. So again, there is another way of doing it, but again, I prefer this one. But if you want to do it this way as well, by all means, you can. Again, just giving you some other options how to calculate it. Okay, so that is probably where for the sample mean, the questions, we stop with the questions. The next will be around the proportion. So let's just get a quick check in. So we've done now the things around the sample mean. Are you a bit more comfortable? Does it make sense? Will it make more sense when you get to the assignments and then be able to use it? Yeah, just some feedback. Well, I'm just quickly making the slides a bit bigger. Okay, cool. Okay, so let's look at the sample proportion. So, and again, you don't need to remember the formulas. I don't remember them. You don't need to remember them. You have enough material that you have in your textbooks and in all the notes, so that you don't need to remember it. So please don't. I know there was a few years ago that they didn't, that it was closed book and you needed to remember formulas, but that is not happening soon again. So please don't not try and remember that when you needed to work out the Z for proportion, that this is the formula. You can write it from the formula page that I still will send you as well. Okay, so this is when we work out the normal or the Z for proportion. This would be your formula. They're asking us the standard error. So when we look at standard error, it's only this bottom part that we need to work with. Okay, so standard error of proportion. So in a binomial experiment with a sample size n of 300 and the sample proportion where p is equal to 0.5, the standard error for proportion p is. Okay, so again, remember when I told you guys, again, it is here. So when we work with the proportion, if it's unknown, we have a p. So in this instance as well, we have a sample proportion. So the only thing that changes in this is the standard error. So this is exactly the same that we would use because it is the standard error of a sample proportion. So we work with the p's. They tell us what that is. They tell us what n is. So we just substitute in the formula. So 0.5, 1 minus 0.5 is 0.5. And we divide that by 300. And that answer we need to, oh, here we go again. That answer we need to square root. So basically 0.5 times 0.5 and then square root. So let me use my Excel for that. And then the answer that we get, I just want to make sure, square root that. And they round it off to 4 decimals is 0.0283. Okay, so it is option 1. I wonder how they, let's quickly, I just want to take the square root out to see if one then at, so if you didn't square root it, the option would have been option 2. So just again, if you get to this and you work with your calculator, if you did 0.5 times 0.5 divided by 300, this is the answer that you will get. So again, just be nearly not too eager to already say option 2. Remember that you need to square root it. And then your answer would be option 1. So again, just be very careful in the exam. I know I've been there. It is when you see one of the answers that matches your calculator, you nearly want to already click it, but we unfortunately need to do another step. And that is to square root that to get the answer, because that is the formula. Okay, so we basically, for previous questions, looked at the sample mean. Here with sample proportion, we've now looked at the error one. I'm hoping that, okay, so that's also standard error. So let's move that to the front, and then we can end off with another standard error. So with this one, they basically asking us to, again, we're working with binomial. So we are looking at to work out the t stat that we need to. So we need to work out the z. So again, just so when we get there, I'll just talk about it a bit more. So remember, this is the formula, and I should have written it down below so that there's at least more space. So let's quickly see if I can just move it. Okay. So let's do that. Divide it by n, and there we want to take the square root again. Okay, so they tell us what the p is. It is 0.35. They tell us what the pi is. It's 0.4. Then they tell us we've got all the other information here, 0.4. 1 minus, so that is going to be 0.6. Divide by square root, or not yet. Divide by 300, and that we need to square root. Okay, so the first thing that I now see is if I say 0.35 minus 0.4, that is actually going to be 0.05 negative. Okay, so my answer is going to be negative. If I look at all of these, only one that's negative is 4. So that will be my answer. So again, tip for the exam is because when we square root something, it can't be negative. That's always a positive. So if your top is negative, your final answer will be negative. So then you can nearly already pick out of these options the one that's negative, and there's only going to be one. Okay, so again, just in the exam, it might be simpler, but let's work out what this portion is that we need to divide by. So that is 0.4 times 0.6 divided by 300. That's weird. It again seems like 0.08, but the square root of it. Probably because everything is nearly rounded off to a certain number that it is like that. So then it becomes 0.05 divided by 0.02824 or something like this, but it continues. But again, for your, when you do you can round it off to 4 decimals or something like that. So if we have then that answer, minus 5 or 0.5 divided by that gives us minus 1,76. Oh, 767. So that is where it was, or it would have been 7,668 if you don't round it off to 3 decimals. Okay, so that is what you will get. And then that was option 4. Okay, they also give you option 1, the positive. You can also see if you worked out the standard error, there was an option for that. The other one, I don't know how you would have gotten the 13. But again, here you can see very similar nearly. If you just had some of the numbers confused a bit, you would have gotten nearly to option 5 as well. Okay, so this was instance where you, again, only needed to work out Z. So you did not need to work out the probability. If you needed to work out the probability, you, depending on if it was bigger or smaller, then you would, please, you round this off to 2 decimals. So let's just do that. So let's say it was minus 1, then 77. And if I needed the smaller area of that, so if I needed this side of minus 1,77, we would have gone to 1,7. Let's just see where that is, minus 1,77, and you would have gotten that. If it was bigger than that and we needed to work out this proportion, we could have just used the positive table of 1.77 because that is the big fat area that we're looking for, 1.77, and there we have the 0.9616. But they haven't asked it, but if you needed to, that is then just the next step that we would have done in any case, like we've done with all the previous questions. But you will see in your assignment nearly as well, they will probably ask you in this, the mean that you work out the standard error. They might then ask you to work out, and that is when assignments you will nearly have one of each, but when it comes to the exam, you will probably get one where you need to work out the probability with a mean. You will get one or about the mean or about the proportion where you need to work out the standard error. And then the one with a proportion is likely to work out the Z. So that you nearly have in each one, you are doing a part of the study unit. Okay, so let's get to this one. In this one, again, standard error that they're asking us. So in the standard error, we basically only looking at this portion of the formula. So we have the 0. So it's 0.68 times 0.32 divided by 20, and then the square root of that. So again, let's using Excel for that, but again, you can use your calculator. So 0.68 times 0.32, you get that answer. You divide it by 20, and then you take the square root. And if you then round it off, So let's look at everything rounded off to 4 decimals. So let's just round it off to 4 decimals. I get 0,1043, 1043. Okay, so, but look, shuch, again, something that is close to a 10, again, if you're just missing it by a bit, if you did not do the square root, you would have gotten that. So again, nearly in a few steps of how you would have calculated it, there's nearly an answer again for a few of them. If we only said 0,68 times 0,32, that would have been also an answer. So again, just be careful when you do this in the assignment that you nearly know what your endpoint is going to be, so that you don't stop halfway through. But again, Peter, to your point earlier this evening, you guys would have noticed, and especially in assignment 2, that you have gotten, in some instances, like 1.5 or 2 out of 4, something like that. So again, if you did only this part, you probably, and you gotten that answer, you probably gotten 1 point. If you divided it by the 20, you might have gotten 1.5 points. And then if you do the square root, you will get your full mark. So nearly again, in that process of working it out, there will be some marks already given to you, even though if you don't get the final answer correct. Okay, so last one, again, standard error. So let's look at what they give us here. Random sample. We're looking for X number of left-handed people in the population. Proportion of left-handed is that. Find the standard error. Okay, so we've got that. Remember, we're now working with population proportion, so we have the P's. Again, standard error of that, so 0.2 will be then times 0.8. And that divided by n, which is 85, and the square root. Okay, so if we then again work that out, if we say 0.2 times 0.8, that is 0,16. At least there is no answers of 0,16. When we divide that by 85, we get, let me just round it off to 4 decimals, or is it 4 decimals? We get 0,0019. So if we only used that portion within, this would have been our answer, but we need to square root it. If you square root that answer, we get 0,43, 0,0434. So that is your correct answer. So again, if we didn't square root, that would have been your answer again. You probably would have gotten 1 or 2 instead of the full marks. Okay, so that is, we actually went through this very quickly. I will just look at some of those notes that is higher up in the presentation. Something went wrong with that, so I just want to take out a few of those, and then I will send this to the WhatsApp group as well. So again, if you new and haven't been in any of the sessions, send me a WhatsApp. If you are also maybe watching this later on YouTube and you're watching it for the first time and seeing there is a WhatsApp group, so just send me a WhatsApp and I will add you to that group. Okay, so this was study unit 7. Questions around this. Or yeah, just hopefully it makes a bit more sense after tonight. And then when you get to the assignment, hopefully it will be then also much better to when you do that. Okay. Next week we're not gonna have a session. I'm on leave next week, a bit of a holiday. So we're not gonna have a session next week, but we will definitely have one the following week.